Hi guys, welcome back to another Shouting Electronics. You might wonder what this flashing thing on the desk is, why it looks the way it does and what it's actually for. So let me give you an explanation. Okay, so I have a customer that has a building that is 20 meters high from the street level up to the top of their building. And basically 14 meters from the top of their building down to a ledge over here, or a facade, and about 20 meters across. So what do you do with such a wide blank canvas? Well, you go and you put LED string lights like Christmas decorations. Okay, so these are more like Christmas lights instead of Christmas decorations. So you have 19 sets of lights, or 19 strings of lights, each suspended with a stainless steel cable that is tensioned between the top of the building and a certain point halfway along. Now you don't just stick with one color, of course. They have got a few different colors. So let's say we've got a red as the first one, and then you've got a white that has every fifth diode or whatever on the string flashes. Okay, so you've got red, white flash, then you've got a steady blue, then another white flash, red, white flash, blue, white flash, and so on all the way to the end. Okay, these are 230 volts, IP, whatever the outdoor rating is. They come in 10 meter lengths, so basically what we've had to do from the bottom of the stainless steel cable, we've got 10 meters, and then we've got a coupling 10 meters up from the bottom. We have another 4 meter piece, and then the rest of the slack is lying on top of the roof where nobody can see it. So this was done basically, it looks nice. It runs Thursday, Friday, Saturday and Sunday every week. But the only animation or the only motion you get is these, every fifth diode in the white flash line is blinking. So I decided, let's spruce it up a bit. Let's take all these 19 lines, okay? Originally they were all just joined at the top with a T piece. So you got our supply coming in, T, T, T. So each of them has a T and they're all connected to power. These things are mains, 230 volts, South African. So they don't draw much current at all. So now what I've done now, I've had my apprentice climb up onto that roof because that thing is flipping high and I don't trust that ladder. And we have gone and taken every single line. We put a junction box on the roof and we've taken a line from each individual strand we've taken to a junction box. Okay, then from this junction box, coming down the back of the building, we've got a 25 core cable. Okay, 25 core 0.5 millimeter cap tie cable. Okay, so core 1 to 19 provides the live for each of these strands starting at this side. So this is 1, 19. Okay, 20 is a spare, just in case, we never know. 21 to 24, those are neutrals. So we say you've got 4 or 5 lines also sharing each onto a neutral. As I say, the low current, so it doesn't matter running that many on a 0.5. Okay, and then 25 is your earth wire, which isn't really needed for these because these are only 2 core lights. Then this 25 core cable travels down the back of the building into a box where this is going to come into. Okay, so this is going to control each of those strands individually. Now, as you can see over here, I've got a 20 LED bar graph here, okay? Each one of these LED outputs represents that one string is going to be on. So this will be string 1, string 2, string 3, string 4, up to string 19. and then string 20, or that's just going to be a spare one for now. I might put an indicator light on the box or something later, but it's just a spare channel for now. That's why you don't see this one lighting up at all. So basically, when you see one of these outputs go on, it then goes and sends a signal to the specific solid state relay on this board over here. Okay, so if you look at this, each of these bar graphs is running off the Arduino. But now, the Arduino, it isn't easy to get 19 or 20 pins giving an output easily. So what I've done is I've got the Arduino controlling three 74HC595 shift registers. That basically loads a shift register and sends the output, which goes to all these LEDs. But also before it goes to the LEDs, you can see it comes out on these connectors over here, which then ties across to these solid state relays. Okay, these solid state relays, basically you give them a ground input and a VCC, which is 5 volts, because these are 5 volts logic driven. And the outputs of my shift register go to all those inputs. If you don't need so many outputs like I do, because I need 19, you might just need 5 or you might need 8. Just take the output straight from your Arduino, which is out of shot there. Take the output straight from your Arduino to drive these logic inputs. Okay. Then on the top here, I've just got live coming in, and it loops through to all of the solid state relays. And then my individual strands will connect 1, 2, 3, 4, 5, 6, 7 of that 25 core cable. And then that is just repeated on the next set at the back. So this is 1 to 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I've just got a smaller 4-port board here for 17, 18, 19, and then my 20 that's a spare. These basically just all connect to the live. Okay, let's go into what the rest of the board does here. So starting on the left-hand side here, we've got a 12-volt switch mode power supply. Just a handy way to drive everything. Even though it does go down to 5 volts, it's just a nice common supply. If something fails with the supply, I can just get a new one and swap it out on site, and they're readily available at a local supplier. I have turned the voltage on this power supply with its potentiometer down to the lowest that it can give, which is about 11.5 volts or so, just to take the burden off this LM7805 voltage regulator. Because the more voltage you're dropping across the regulator, the hotter it gets. So I'm just lowering that voltage a bit more before it gets here. As you can see, I did put a heatsink on as well, because although the Arduino doesn't draw a lot and the shift registers don't draw a lot, these solid state relay boards. So if we look at the data sheet, we can see that these solid state relays here draw quite a lot when all the outputs, or all the inputs are getting signaled. Doesn't matter about the outputs because they're on the other side of the triax. But yeah, the inputs are drawing quite a lot, and if you add it all up, it works about over 200 milliamps if you got power coming into all the inputs at the same time, which was making this regulator quite a bit warm. That's why I went and I put just a heatsink I had lying around, and I put a bit of thermal paste on there. And that's basically it. I've got 2 buttons over here that I can program. I might program one in as a test mode and one for speed or manual pattern changing or something. But this is designed to run automatically. As soon as the timer for those lights on that building's tower activates, this thing must just kick into gear and run what it's doing. Basically how I get this pattern going here is on the Arduino program that I've got, the C program. I've defined an array that's got 32 bits, uint32_t or whatever. And I've just done basically a whole bunch of binary inputs. 0B, 00010101, wherever there's a 1, that light will be on, and then it shifts it out to the shift registers. So it is quite a long array. It's basically endless what I can do in code. And what's nice is because it's got the Nano with the USB socket on the side, I can think of more sequences in it. I can program them onto my laptop, just bring my laptop, plug it in upload the program straight away. But basically I load the new code in, bing, and it will automatically run. So what I'm going to do now is I'm going to take this, I'm going to install it on the building, on site. I will show you when I'm up there on this. I'm not going to go right on the roof, I'm going to go to where the junction box is, where I can easily reach it, the control box. Slot this in, connect it up, and then we'll actually take a look at the lights on the building, how they look during the daytime, when you can't see them glowing during the day because the sun is quite bright down here. But then we'll also take a look at night and we'll see the sequence, how it's busy working, and if it looks as good as I hope it's going to look. It should look a lot better than static, and it should draw a lot of attention, so that's a good thing. So let's take it and go and install it. Before we do, just one thing I forgot to mention, and I know I'm going to be asked about this. Why didn't I get a printed circuit board made from JLC PCB or anybody like that? This was a bit of a time crunch to get done. So the best I could do was just, in the meantime, let's unplug it. So what I've done with this one is I've bolted onto this prototype Invero board. As you can see, it's got all the strips there, and I just used a drill bit to cut out where I don't want the tracks continuous, and then just soldered all the parts in, did the little jumpers where I needed to. So this is a quick and easy way to get it up and running without having to wait for if it is going to come, if the postal service is going to deliver it and things like that in time. What I would have preferred to do is make one large board that has all this on the board, all surface mount. That would have been nice. And then also the solid state relays, I could have put the MOC 3021 opto isolator, or opto isolator, driving BTA 05 or BTA whatever triax, because we don't need much currents. And it would have been a lot neater all on one board. I wouldn't have had to have all these wire jumpers and that. But this is just how we got it going for now. If I do have time, and if there is more of a need for me to redo this, then I probably will design a printed circuit board and get it made. But yeah, this works for now, and I'm sure it will work for a long time. What I also did is, after I assembled it and tested it and that, I spray painted this whole board with a clear silicone varnish. So it is a bit sticky at the moment because that was done recently, but that should keep all the sea air out, because we are right, the building is right on the beachfront basically. Then also, because the enclosure that this thing was going to go into was a bit on the small side, which I only realized later when I got the solid state relays and that. That's why I went and I put these little pieces of cut up 3-phase DIN rail. Okay. I've got a screw going through the center, and I've got them actually epoxied down onto this piece of plastic here, just to keep them standing up. Keeps everything away from everything else, so we won't have any tracking or anything like that. It's held in securely. If I do have a problem with one of the solid state relays or whatever, I can just slide out the module, undo a few wire terminals, and away I go. I can work on it, or I can get one or two spares and swap out as needed. And there she goes. Okay, so now let's go to the building. Once I'm finished tightening all my nuts. Okay, so there is the ladder. I'm actually standing on one roof of the building. There's the ladder that goes right up to the top. And let's take a walk forward to where the box with our 25 core cable is. Okay, I'm still in the process of busy wiring it up, but there is our board in its box, and the 24 core cable comes out the bottom. Over there it's the grey one, and it goes all the way up the side of the ladder to the top, and then I'll show you some pictures of what it looks like on the top. once I went and put the control box in basically and we wired up all the lights to it, we had two problems. One, the strings of lights were quite dim. Okay, but that would have been like that before because all those LEDs in those strings, I'll show you over here. Supply comes into the string through a resistor, and then it's got lots of LEDs, and then it goes basically to neutral. Now if you'll see, all these LEDs are facing the same way, which means they're only going to light up when current goes one way. And with your alternating current, in South Africa, 50 times a second is busy alternating. So they were not getting their full brightness, they were getting half the power basically. And then also I had another problem where some of them wouldn't turn on. Some of them wouldn't turn on the strings randomly, and some of them would not turn off randomly. It was just a very strange thing. So then I looked at the data sheet for the solid state relays that I'm using, and it shows that it needs a holding current of 0.1 amps, which is quite a lot considering these lines draw so little for each line. So then I went and posted on the EEV blog forum about this problem. I said, listen, I don't want to put a resistor there because the resistor is going to get hot just to meet the load. What can I do? And then if you look at the replies on the forum, one of the posters suggested a snapper, capacitor, and resistor. So here is the live that comes into the solid state relay. Let's just do SSR. Solid state relay goes out to the LED string through the resistor, and it goes to neutral. Now what he recommended I do is put a 100 ohm 2 watt resistor to, that's not a resistor. Okay, so what he recommended is we take a resistor, 100 ohms, at least a 2 watt resistor, and together with a capacitor, 100 microfarad class X capacitor, because it's going across the live and the neutral, so the class X is safety rated, so if it won't actually short out, and they sometimes self-heal themselves, and that if it does fail, it'll just fail open circuit. Okay, so this is what we ended up doing, including the snubber and converting the alternating current to direct current to get the LEDs working a bit brighter. So we took the live that went into the solid state relay. Hope arm's not in the way. Okay. And this is the 25 core cable that's running up to the top. Okay. So this is the first solid state relay output number 1. We took it into a bridge rectifier. Give us positive and negative, which then we ran to our LED strings. And then you're saying, what about the snubber? We put the snubber in there before the bridge rectifier. So basically that does the snubbing and everything, as suggested by the EEV blog member. And then this converts the AC to DC. Let me explain the brightness situation and how the bridge rectifier solves that. Okay, so say this is our graph of our mains power in South Africa. Alternating current, 230 volts. 50 hertz, so 50 times a second it does the cycles. So it does that cycle 50 times a second. Let's do just 2 complete cycles so you can get a gist of what we're doing here. Now then, if you look at the top here, because those LEDs were only getting power one direction and they're all facing the same way, they were only lighting up during those top parts of the cycle. During the bottom part of the cycle, nothing. So they were a light and then dark, light and then dark, light and then dark, which actually made it dim. So what the bridge rectifier actually does when it goes minus, it goes and it turns it around. So it keeps it as a positive cap there. Positive cap. Hope my graphs are lining up. And positive there. So now instead of just having 2 highs, we got 4 highs. Okay, so we got double the amount of power. We do have those little dips between those, but that's not too much of a problem. If we wanted, we could put capacitors in that, but it's not needed because those lights actually look bright. If we did put a capacitor on, it would have smoothed the wave. Something like that. Okay, so now that you got why we've done it, look at this box over here. It looks a mess, but basically that's got 19 channels in it. Each one with the bridge rectifier and the snubber capacitor and snubber resistor there. All wired up. This is on top of the building. And this is the result. So I hope you enjoyed this little project. It's actually quite a big project. It gives a big output, 20 meters by 20 meters really, or 20 by 10 meters. So it's quite a nice attraction there. It looks nice, it works nice, it's bright, it gets your attention, and it's easy for me just to change the program in as I need. Well, I hope you enjoyed that as my last video for 2021. And let's release a lot more videos in 2022. If you liked it, please give it a thumbs up, like and click the bell icon, and you'll be notified whenever I upload new videos. Thank you, and thank you for your support throughout the year.